Hello and welcome to Math 252. This is the third lesson on a series of lessons that we had on linear programming. In our previous lessons we have looked at the formation of linear inequalities, and we have also seen the solutions of linear inequalities. In this lesson we are going to discuss the graphical solutions of linear inequalities. How linear inequalities can be solved graphically is what we are going to discuss in this very lesson. And I therefore have to say the following points before we start on showing the solutions of linear inequalities graphically. Solutions to linear inequalities formed to represent given conditions can be determined by graphing the inequalities and then reading off appropriate values. Those appropriate values are typically called the possible solutions of the inequalities. So there are certain tips that we need to understand on pertaining on how we can graph given inequalities on a piece of paper or maybe on a Cartesian plane. So the point number one that we need to be familiarized with is once you form an inequality, you express the inequality in the form of equation, and you give your equation in form of y is equal to mx plus c. That is in the form in which the equation of a straight line can be given. So you must give your equation in this form before we start plotting, or we get maybe the points that we need to plot for the inequalities. Point number two, the signs such as greater than or equal to or less than or equal to are usually represented by a solid line when we are drawing on a piece of paper. That is a continuous line. While the signs such as greater than or less than are represented by dotted line. So when you have this sign that is greater than or equal to, less than or equal to, or greater than or equal to, then the line that you are supposed to represent should be given in solid line in form of a continuous line without dots. But when the inequality used is either greater than or it is less than, then the line should be represented by a dotted line. Point number three and the final one, once you draw the line which we are calling the boundary line, then the inequality you have will either take the points above the line or below the line, or even the either side, and therefore we need to identify the wanted region. So to get the wanted region, we normally pick a point on either side of the line, substitute it with the inequality that you have, check if it makes mathematically sensible statement, then you shade the unwanted region. So if the statement that you have obtained does not make any mathematically correct statement, that means the point that you have chosen is found on the unwanted region, and therefore we shade that part. But if it makes mathematically sensible statement, it means that the point you have chosen is found on the wanted region, and therefore we shade the remaining side. So let's see examples. Example number one, you are given a student wishes to purchase not less than 10 items comprising books and pens only. A book costs Sh20 and a pen costs Sh10. If the student has Sh220 to spend, form all the possible inequalities from the given condition and graph them, indicating the possible solution. So you have a student here who wishes to purchase not less than 10 items, and those items are books and pens. The cost of a book is given as 20 shilling, while the cost of a pen is given as 10 shilling. And the total amount of money the student has is 220 to buy those books and pens. and we therefore need to form different inequalities or all possible inequalities from this very statement given. So let's say that the number of books purchased is X. So we can let the number of books the student purchased to be X. We can also let that the number of pens purchased by the student be Y. So we assume that the number of books the student got or maybe purchased is X, while the number of pens he or she purchased is also Y. So reading again in the statement given is that a student wishes to purchase not less than 10 items. This means that the total number of items should not be less than 10, and therefore it should be 10 or more. That means the number of books plus the number of pens purchased must be greater than or equal to 10, and therefore that is the first inequality that we can make. That is, the number of books plus the number of pens should be greater than or equal to, because here you are told should not be or not less than 10 items. So that is now the total number of items purchased must be greater than or equal to 10. So then we move from this inequality to an equation so that we can get the arbitrary values for X, and then we find the corresponding values of Y. So we can say let X and Y is equal to 10. We just substitute this inequality to be an equal sign, and then we can draw this straight line. So this one represents, this inequality represents a region, and therefore we cannot get a region unless we get the boundary, which is now the equation of that straight line. So you can take the value of X and Y, and we can get the corresponding values in each one of them. Then I found it is important, or it may be easier, that we can find the X and the Y intercepts by simply substituting X to be 0 in the first time, and then Y to be 0 on the second time, so that we can get the corresponding values of X and Y. So when X is 0, Y is 10. That is, we substitute 0 here. That is 0 plus Y is equal to 10. And therefore, Y becomes 10. On the other side, you can also substitute Y to be 0. So once you substitute Y to be 0, you have X plus 0 is equal to 10. And therefore, X becomes 10. These are the points that we are going to plot on the Cartesian plane. So therefore, then we can obtain the boundary phase. The second inequality that we can form is that a book costs shilling 20 and a pen costs shilling 10. So the price of a book is 20 and the price of a pen is 10. Then the student has 220 shilling to spend. That means the total amount of money he has to spend should be 220 or less. It should not be more than 220 because the budget is exactly 220, and therefore the total cost for books will be 20 shilling times the number of books, which is X, then plus the total number of pens, that is Y, times the price of a book, which is 10Y. So 20X plus 10Y should be less than or equal to 220. That is the second inequality that we can form. That is 20 times X is the total amount of money spent on books, plus 10Y, that is the total amount of money spent on books, should be less than or equal to the total budget, which is 220. Then we can move now from an equality to equation. This one becomes 20X plus 10Y is equal to 220. You can either simplify this one 0, cancel 0, 0, then you can have 2X plus Y is equal to 22, or you can simply have the way it is. The value of X and Y will not change even if you have not simplified. But if the number is very long, then of course now you can simplify. So let's also get a table containing X and Y. That is, when X is 0, Y becomes 22. We simply simplify this one, you substitute this one to be 0. Therefore it is 20 times 0, which is 0, plus 10Y is equal to 22. So 10 divided by 220 is 22. So we also let Y to be 0, and then in that case X becomes 22. We substitute Y to be 0, and it becomes 10 times 0, which is 0. Then we have 20X plus 0 is equal to 220. 20 divided by 220 gives you 11. So those are also another table that we are going to use. These are the X and Y intercepts, and these are the points that we are going to plot on the Cartesian plane, or maybe on the piece of paper, that is a graphical paper. Then we can get now the boundary of the inequality. Then there are other obvious inequalities that we have already discussed, that how they can be formed. So we can assume that the number of books bought should be greater than 0. That means the student have to purchase, even if it's a single book, then he has to get certain books or number of books, and therefore x should be greater than 0. That is that inequality that we are normally call it the obvious equations, or maybe obvious inequalities. Then maybe you can move this one to an equation, and then x becomes 0. This is the horizontal line. Sorry, this is the vertical line, y-axis. So we draw now on the line y-axis. That is the equation of whose maybe the line whose equation is x is equal to 0. Then the fourth equation, which is also the obvious one, is that we also assume that the number of pens bought should be greater than 0. Therefore, the student has to get number of books, whether it is 1, 2, or more. The value of y should be more than 0, and then this is also y is equal to 0. This is equal to 0. So then y is equal to 0. That is the horizontal line x axis. So we are going to also to draw those lines. That is x is 0 and y is 0. So let's now plot those all those lines, and then we shall find out the visible line or the region that will should be satisfying all these inequalities that we have. Let's get a Cartesian paper or a piece of paper, that is the graphical paper. We shall start with the first line, that is x plus y is equal to 10, and we have obtained the x and y intercepts as 0 and 10. Sorry, 10 and 10. So we plot the points 0, 10, 10, 0, that is on x-axis, and then also the other line on y-axis, which is 0, 10. So those two lines, we will plot them, and we therefore join together to form the straight line. That is it. We got the line whose equation is equal to x plus y is equal to 10. That is the line, or the line whose equation you obtain like that. So from the drawing of the line, we also need to get the region. So this is the boundary of the inequality. So the inequality we had can either be falling on the above the line or below the line. So we need to get now which region will be satisfying the inequalities that we have obtained. So how do we get that one? We get first of all the inequality of the line, that is x plus y is greater than or equal to 10. Then from there we pick a point on either side of the line, substitute it in the inequality we have, and find or see whether it makes mathematically sensible statement. If it makes, then the point chosen is found in that region, and if it does not make, then the point chosen is the unwanted region, and we therefore shade that particular region. So let's pick a point. So we pick point 0, 0. I have found it is easier, we pick point 0, 0, and then if 0, 0 is a point we have picked, and we substitute this one in the inequality we have. So if x is 0, y is also 0 in this case. That means 0 plus 0 will give you 0, and then 0 is greater than or equal to 10. That is the statement we are getting. 0 is greater than or equal to 10. This is mathematically not sensible. This is not correct, and therefore we can say that this is mathematically incorrect. So if this is mathematically incorrect, it means that the point chosen is found in the unwanted region. So the point 0, 0 is found in the unwanted region. So if this point is found in the unwanted region, means that the region that will satisfy the inequality is the above region, and we therefore shade this region which is below the line, and we shade it like that. So that is the region that is not satisfying the inequality, and therefore any point which is above this line will therefore be satisfying the inequality of that form. We also take the second line, that is the inequality, the equation was 20x plus 10y is equal to 220, and the x and y intercepts were 11 and 22 respectively. Therefore, we plot the point 0, 11, and we also plot the point 0, 22, and we join them with a straight line like that. So once we obtain the straight line, we can as well note maybe or write the equality. The equation is 20x plus 10y is equal to 220. We do also the same process, that is, we supposed to identify that the region that will be satisfied the inequality, above or below. We also take a point either below or above and check whether it makes a mathematically sensible statement. So I've also chosen the points 0, 0. So if that's the equality we had, that is 20x plus 10y is less than or equal to 20, and we picked the point 0, 0. We substitute this 0, 0 in the initial inequality that we have. If x is 0, that is 20 times 0, which is 0, plus 10 times 0, which is 0, then it becomes 0 is less than or equal to 20. This is mathematically correct. It means that the point we have chosen is found in the wanted region. So this is mathematically correct. 0 is less than or equal to 20, and therefore the point that we have chosen, which is 0, 0, is in the wanted region. So if this point is in the wanted region, therefore the region we want is this region below the line, and we therefore shade this line above, or this region above the line, and we shade it like that. Now, so far we have obtained the inequalities or the points or the graph of all those. Now, so once we draw those one, then we are remaining with the remaining two lines. That's when the first line was the line y x is equal to 0, which we said is the y-axis. So this already it is drawn. So we only need to get the region which will be satisfying also the inequality of that line. So let's just name that line, because it's already drawn, x is equal to y. And the inequality of the line we had was x is greater than 0. So if we check this line, on this line, any point on this line, x is 0. And any point on the right side of the line, x is positive and therefore greater than 0. And any line on the left side of that line, x is negative. And it means that those lines that are found on the left side of the line, x is less than 0. So therefore the line or the region we are interested with is the region where x is greater than 0. And it is on the right side, which is the positive side. And we therefore shade that left side, which is x is negative. Then the last line is line y is equal to 0, which we said is the horizontal line x-axis. This line is what y is 0. So it's already drawn. We only need to name as it y is equal to 0. Similarly, any point on this line, which is x-axis, y is 0. This point where 4 we have is 4, 0, 3, 0, 2, 0. It means all the points on this line x on y, any point of y on this line is 0, and any point above the line y is greater than 0. Any point below the line x is negative and it is less than 0. And therefore we are interested on the points that are greater than 0, because the inequality of the line was y is equal to, or y is greater than 0. And therefore we are interested on the points that are above the line, and we shade now the below or the side which is negative, y on the negative side of y. So this is how the inequalities or the points, or maybe the inequalities of the equations of given inequalities can be obtained, maybe the graphical solutions. And this region that is bounded by all the lines, this region where now I have the cursor, is the region which we are called the visible region, that can satisfy all the inequalities from this point until maybe we reach on the top far end. All those points are the points that will be satisfying our inequality. We can name this region maybe region R, and any point picked in this region will therefore satisfy our inequality. This is how solutions of inequalities can be obtained using graphical methods. This is the end of our lesson today. We shall be having one more lesson on this topic where we shall be seeing how we can optimize the values maybe, or the optimization, finding maybe the maximum or the minimum points of a given inequalities. In this case, we have so many solutions. All these points that are within the graph can absolutely give you a solution for these inequalities. But if you want to narrow down our discussion maybe to a particular point that is either the maximum or the minimum point, then we need to do what we are calling the optimization, and we shall make a video on that subtopic in our next lesson. That is the end of our lesson, and I wish you all the best.